So hello students, today we discuss about the worksheet 1 based on redox reactions. Okay, there is also exercise 1 in the redox reaction. So first is the first one in that worksheet, that is the solution of sodium metal in liquid ammonia. It acts as strong reducing agent. Actually, for this question we also have to remember a important point. So the sodium metal in liquid ammonia works as a good strong reducing agent. We have to remember this question also as an important point. So how it works as a good reducing agent means so this is known as due to the presence of electrons in ammonia. So they known as ammoniated electrons. They known as ammoniated electrons. They are also known as solvated electrons. So the simple reason is due to the solvated electrons, nothing but ammoniated electrons, sodium metal solution in liquid ammonia is acts as a strong reducing agent. Okay, so a very important point. Next, see the second question. So the white phosphorus react with the caustic soda. So the question is given that white phosphorus react with caustic soda. So the products are, so given that the products are phosphine PH3 phosphine and given that NaHP would sodium hypophosphate. This is called sodium hypophosphate. Sodium hypophosphate. The reaction is an example of ash. So we have to write the reaction. So we have to, so already it is given the products also, but it is not compulsory they will give the product. They simply give the reaction of white phosphorus with caustic soda. We have to know the products and we have to do the further question. So we have to know what type of a reaction is there. So white phosphorus means that is P4. Just remember the formula of white phosphorus is P4 when react with the sodium hydroxide. So it takes place in aqueous medium, forming what are the products? The products are given phosphine, sodium hypophosphate, sodium H2PO2. Okay, so just balance it. 4 phosphorus are there. Here 1 phosphorus, maybe 4 phosphorus, 3 NaOH, H2. Okay, in the stoichiometric problem we have to know this reaction also. Now we have to know what type of reaction is this. This is an example of which compound. So here, so it is a redox reaction. Means here oxidation takes place, reduction takes place. But again, what is the importance of this reaction is not only simple redox reaction, it is a disproportionation reaction. Disproportionation reaction means we know that only one element. So what are the disproportionation redox reactions? Only one element undergoes oxidation and also reduction. Okay, here, so we can't compare any other oxidation numbers except phosphorus, because sodium always +1 in the reactants and products. Oxygen always -2 in the reactant and phosphorus. The hydrogen also here +1, here also +1. Means we can compare the oxidation numbers of phosphorus only because there is a possibility to change in the oxidation numbers is only in the phosphorus Okay, now we see what is the oxidation number of P4. P4 means the free element, it's 0. So in pH3, what is the oxidation number? So here calculate here only. So phosphorus, say X plus 3 equals 0, X equal to minus 3. So here sodium 1, 2 hydrogens 2, 1 phosphorus simply X, 2 oxygens means minus 4. Each carries minus 2, okay? It's X3, it's X minus 1. So here the oxidation number. So the oxidation number from P402, here pH3 is become minus 3 means reduced. Here phosphorus undergoes reduction. Here oxidation number of phosphorus increased from 0 to plus 1 means it is oxidation. So both reactions takes place. It is a redox reaction. Only one element undergone oxidation and reduction. So therefore this reaction is an example of here P4 is oxidized and reduced. So therefore it is, I mean this reaction is a disproportionation redox reaction. Okay. So see the next question. I think it is the question number 5. So just don't take the direct notes. You have to understand the problem. That's the important one. Just writing in the notes, completion of the notes is not important. You have to understand the problems. See the question number 5 that is given. The number of moles of potassium permanganate that will be needed to react with 1 mole of sulfite. 1 mole of sulfite ion in acidic medium. An acidic solution is dash. So again here important, we have to know the reaction. Here that no products are given. So by observing all these questions, I got the point that for many problems you have to remember the reaction also, because in all problems they are not giving about the products. So you have to remember. I can say you have to by heart the total reactions which are coming in our worksheets. Okay, so first we read the reaction between the potassium permanganate and sulfite ion in acidic medium. So what is the reaction is? Actually the main reaction part is the permanganate part in the KMnO4. So we are writing it in terms of ionic form. This is sulfite ion and acidic medium, it is H plus. So in all books it is given like this only. So you have to remember this one is better one. Mean here sulfite. The sulfite is changed to sulfate. So here is exactly the given number of moles. So balancing is compulsory here. So in the problem was just they asked what type of reaction under. So కాబట్టి మనకి which is oxidized, which is reduced సరిపోతుంది. కానీ exactly number of electron find out చేయాల్సి వచ్చినప్పుడు, how many number of moles find out చేయాల్సి వచ్చినప్పుడు we have to compulsory write the equation, sorry, we have to write the balanced equation. Okay, so see the manganese sulfide, if you compare the hydrogens mainly, so only a balanced 2MnO4. So yes, here we have to find the number of moles of this potassium permanganate, nothing but permanganate ions. So it is given in terms of moles లో ఉంది కాబట్టి ఆల్రెడీ ఈక్వేషన్ లో కూడా మనకు వచ్చేవేంటిది, ఈక్వేషన్ లో ఉండే దిస్ కోఎఫిషియన్స్ ఇన్ ద రియాక్షన్ ఆర్ ఆల్సో moles. ఇక్కడ ఉన్న మనకి 2 ఉంది, నథింగ్ బట్ 2 moles, 5 moles, 6 moles. కాబట్టి we can do the problem directly. Here see 5 sulfate ions. Here it is 2 moles. Here it is 5 moles. Mean 5 moles is reacting with the 2 moles of MnO4 minus. Means with the help of the problem ఏ మోడల్ ఇచ్చిందో అదే మోడల్లో కన్వర్ట్ చేసి we write in sentence a correct sentence. So that is for 2 moles, sorry, for 5 moles, for 5 moles of sulfite we need 2 moles of MnO4 minus. Then what about for 1 mole? So very simple. After knowing the equation it become very clear that with the help of equation we write the 5 moles of sulfite, 5 moles of sulfite ions to oxidize. Actually the sulfite ion is oxidized to sulfate, need 2 moles. This is according to the equation. 2 moles of sulfite, 2 moles of sulfite ion for complete oxidation. Okay, 5 moles of SO3 minus 2 ions require 2 moles of SO4, sorry, so they are formed with need 2 moles of permanganate MnO4 minus. Then what about 1 mole? Simple. 1 mole of sulfite ions need how much? How many moles of MnO4 minus? Class multiplication. So we get 0.4 moles. 0.4 moles of potassium permanganate is required. Next, see the similar problem, that is I think question number 6. See the question number 6. The potassium permanganate oxidizes oxalic acid. So given that potassium permanganate oxidizes oxalic acid, so already we know potassium permanganate, potassium dichromate, these two are best example for oxidizing agents. The oxidize oxalic acid, so in acidic medium, so we have to find the number of CO2 molecules produced. The number of CO2 molecules produced is dash. Okay, so for this also we have to know the reaction. It's a compulsory. So already I said you have to remember the reactions. So the potassium permanganate oxidizes the oxalic acid H2C2O4 in acidic medium. Generally it requires sulfuric acid, and we know that the products are manganese sulfate. The potassium is there, so automatically it compulsory forms potassium sulfate, and even in the problem it is given it forms a CO2 and it's also H2O. So just knowing oxidation and reduction, so it is sufficient. But here we have to calculate the number of moles, not only number of mole. I think I have to find the number of CO2. Okay, number of CO2 moles. So number of CO2 molecules is given in the question. So first we find the number of moles, then we convert it to number of molecules. So first balance the reaction. So here already I balanced it. 3. How many carbon dioxide? It is 10. Is alright. So just we have to remember in this reaction how many number of CO2. So in this reaction 10 moles of CO2 is formed. So the answer directly we can write 10 moles of carbon dioxide is produced. But here it is given in terms of number of molecules. So in terms of molecules, so 1 mole equal, we know that Avogadro number. The 10 moles means 10 into 6.022 into 10 power 23. The 4 molecules of CO2. Okay. Okay, we have to, so what my suggestion is, you have to take the reactions at one place. Okay, after completion of the total problems, write the reactions in a separate page, and you have to add that. Okay, at least daily once you have to write the reactions and practice it. Okay, see the next question. Exactly, that is question number 7. So the question is, with which of the following which of the following SO2 reacts as oxidizing agent? So the options are given. Acidified potassium permanganate. Next, acidified potassium dichromate. Next, acidified ethyl alcohol. And the last one, aqueous hydrogen sulfide. So we have to compare that, check the all options. So with which of the following SO3 sulfur trioxide reacts as oxidizing agent, means in which of the following compounds sulfur trioxide acts as oxidizing agent. So oxidizing agent always generally react with the reducing agents only. Okay, so here you see the potassium permanganate. Already just now in the last problem we said it is a strong oxidizing agent. So again oxidizing agent reaction not possible. Here potassium dichromate also like that. It is also weak oxidizing agent. Same, the remaining is H2S. H2S means the SO3 works as reducing agent only with H2S. Above generally these two are mainly perfect oxidizing agents. So and we know it is not SO3, it is SO2. So we have the reaction that SO2 when react with the H2S. There is a formation of H2O and sulfur. Okay, means SO2. Here SO2 on reacting with the SO2, the sulfur S minus 2. The sulfide is changed to sulfur, means it is oxidized from sulfide to sulfur by reacting with the SO2. Okay. Okay, here two sulfurs. Okay, write it as the two sulfurs. Okay. So here the four sulfurs becomes. Okay. So no need of balancing equation. Just this is the answer. Let's see the question number 9. See the question number 9, that the question is in the reaction. So the reaction is given C2O4 minus 2 plus MnO4 minus plus H plus. So it is directly given in the question. Manganese ion and carbon dioxide and H2O. We have to find the reductant is. In the question we have to find the reductant is. So looks very simple. So reductant means which reduces the other compounds. Which reduces the other compound means we have to find the reducing agent. So first we have to know what is the meaning. Reductant means, so there is nothing but equal to reducing agent. There is a reducing agent. Reducing agent means already we know that itself, reducing agent reduces the others and itself it is oxidized. Itself it is oxidized. These are the three meanings. So here, now we have to find what the reductant means. We have to find which is oxidized. So compared, here manganese oxidation number +7, here it becomes +2, means it is reduced. But we want to know which is oxidized. Which is oxidized, then only we can say it is as reducing agent. So obviously C2O4. Okay, in the C2O4, what is the oxidation number of carbon? So 2x minus 8 equal -2. So oxidation number of each carbon is 3. So 2 carbons having 3, 3 oxidation numbers. So if you balance it, 2 carbons. So here carbon oxidation number x minus 4 equals 0, x equals 0. Means 2 carbons are having 4 oxidation number 4. So one carbon 3 to 4, other carbon also 3 to 4. Means their oxidation number losing means this is -1 electron, this is -1 electron, totally losing of 2 electrons. Losing of electrons means itself they are oxidized, they works as reducing agent. Means what is the answer? The answer is C2O4 minus 2 works as reducing agent because itself it is oxidized. Okay, next see the question number 11. So the oxidation and reduction species respectively of the reactants. So a reaction is given Br2 plus OH minus indicating the basic medium and the forming Br minus and BrO3 minus plus H2O. We have to find the oxidant and reductant. Oxidant is what? Reductant is what? So just now we discussed Oxidant means oxidizing agent, itself it is reduced. Reductant means reducing agent, itself it is oxidized. So if you see the reaction, there is only possibility of bromine to oxidize and also reduce, because there is no change in the oxidation number of oxygen, there is no change in the oxidation number of hydrogen. Now there is a possibility of changing of bromine. Bromine is changed to Br minus in one reaction. In other reaction, so Br to change it to BrO3 minus. Here we are not going to the balancing the number of electrons, just we are observing what is the reaction. Br to 0 to minus 1 means it is reduced. So here reduced means it works as oxidant. Itself it is reduced means it works as oxidant. Here Br to 0, what is the Br oxidation number? X minus 6 minus 1, X equal plus 5, bromine plus 5. And bromine oxidation number changed from 0 to plus 5. So it is oxidized. In this change, bromine is oxidized. Bromine oxidized means it works as reductant. Mean for both questions, what is oxidant, what is the reductant? So the answer is only one, that is bromine. Bromine is works as oxidant and also reductant. Okay, next see the question number 12. So the total number of electrons involved in the oxidation of C2O4 minus 2 to carbon dioxide. So just we know that it is a oxidation reaction is given. So we have to know the number of electrons. Kabatti we have to balance the reaction. Okay, balance that change. Okay, to carbon dioxide. Already we calculated the carbon oxidation number here. S equal we will get 3, but two carbons are having like this 3, 3. Here two carbons are having 4, 4 means just I think just now we got it. Totally there is a losing of 2 electrons. Means 2 electrons, or we can say 2 moles of electrons. For 1 mole of C2O4 require 2 moles. So it is in terms of options we have to say 2 moles are given if that is the correct one. Okay, 2 moles of electrons. So yeah, always remember to know the exact number of electrons, to know the number of moles, we have to balance the reaction before going to the calculation process. But what type of reaction means if it is the question is what type of reaction, oxidation or reduction or redox or which type of redox, disproportionation or comproportionation, just what is the type of reaction, balancing is not necessary, but to calculate the number of moles or other stoichiometric calculations or number of electrons, you have to balance the equation. Okay, next see the question number 13. So which of the reaction there is no change? So the question is, in which reaction where there is no change in the oxidation number of elements. So actually I am not writing the total options. Here there is only one option is there. I am directly writing the answers. I am not giving the all options. So the reaction in which there is no change in the oxidation number of any element means there is no change in the oxidation number of a single element also. That reaction is, I am directly writing the answer, I am not writing the total options. Okay. Here see, what is the oxidation number of sodium? Here +1, here also +1. Here oxidation number of sulfur, calculated +6. Here also +6. In all these compounds, oxygen having -2. In these compounds also oxygen -2. Hydrogen is always in +1. In these compounds also hydrogen is +1. So here one important thing is oxygen -2, oxygen -2. In this compound only oxygen -2. What about in this compound? This is a peroxide. O is in -1 oxidation state. Okay, so this is also peroxide. Here O2 is O is also -1 oxidation state. Mean nothing is changed. All oxidation numbers of all elements are exactly like in the products. Means oxidation number of the all elements is exactly same in the products when compared to the reactant. So this is the question. Okay, so this is the completion of 13th question. Next, see the 14th one. The number of electrons. Number of electrons involved in the reaction of dichromate to chromium ion and acidic medium. So already the change is given. So already we done this type of problem. Okay, here we have to find the number of electrons. Number of electrons, we must balance the equation, that is 2Cr plus 3. So what is the oxidation number of chromium here? 2x minus 14 minus 12. So here x equals means 2 or 2 chromiums collect the oxidation number, we will get 12. Means 2 chromiums are in +6 position, 6 comma 6. Here 2 are +3s. Okay, means here the oxidation numbers are +3 and +3. 2 chromiums are having, means 12 plus 6. What is the change? 6. So means we can write. So oxidation number is decreased. Oxidation number decrease means gaining of electrons. So what is the change? Means the number of electrons involved. Number of electrons involved means 1 mole of dichromate. 1 mole of dichromate gains 6 electrons. 6 moles of electrons. Okay. In normal classes, we discussed many problems like this. I think already same problem also we done. Okay, see next. The equation is given, and O3 minus 2H2O plus NO. What is the question? Is the number of electrons it is given in acidic medium. So the question is, we have to know the number of electrons added for balancing the reaction, balancing this reaction in acidic medium. We know the acidic medium rules. What are the acidic medium rules? So we know that acid medium or base medium first balance the other atoms than hydrogen and oxygen, then balance the oxygen using H2O molecules and hydrogens using H plus ions. Okay, simple. So then only we were able to balance the electrons. Here 1 nitrogen. So what is the change? NO3 minus 2 NO. 1 nitrogen, no problem. Here 3 oxygens. Here only 1 oxygen. So NO3 minus NO. 3 oxygens. Here 1 oxygen. 2 hydrogens are less. Let's go to H2O. Then here 4 hydrogens. Here there is no hydrogens. So we can write direct step, that is 4H plus. Next, what is the charge here? This is plus 4, this is minus 1, total plus 3 at the left side charge. Here it is 0, 0, the total right side charge is 0. So where the charge is highest? 3. So what is the process to add the electrons? You have to add the electrons where the charge is highest in how many units. Here what is the highest charge? Here 3, 0. This is the 3 units higher at left side, so we have to add 3 electrons. Means charge ఎక్కడైతే ఎక్కువ యూనిట్స్ ఉందో, so ఎన్ని యూనిట్స్ ఆఫ్ చార్జ్ ఎక్కువ ఉందో అన్ని యూనిట్స్ ఆఫ్ ఎలక్ట్రాన్స్ యాడ్ చేయాలి. Now what is the answer here? The answer is we have to add the 3 electrons at the left side. Okay. Okay, see the next one. So equation is given that 2CrOH taken 3. So the reaction is given in basic media. What we have to find? The number of OH minus. Find the number of OH minus to be added at a reactant side. So again the balancing question. So first we see only one change. Okay, we can take any one of the changes. Okay, you can take the chromium change, the iodine change, we can take any one. Okay, so first take the 2 chromium, take it 3, so it is given already balanced. So after this we do this also. Here so given the basic medium. What are the basic medium rules? The basic medium rules is first balance the other than oxygen and hydrogen. Next balance the oxygen. For oxygen use the H2Os. For hydrogens use the OH minus and H2Os. Sorry. For hydrogens you also have to use the H2Os and add the same number of OH minus in the opposite direction. We always follow this rule only. So 2 chromium, 2 chromium. Now see the oxygens. Here 6 oxygens. Here 8 oxygens. So oxygens are less, but 2 oxygens are less. So add 2 H2Os. Then balance the hydrogens. Here 4 hydrogens. 2 to the 4. 6. There is 10 hydrogens are there. Sorry. 10 hydrogens are there. Here no hydrogens. So how to balance the hydrogens? So where the hydrogens are less? Here. So add the same number of H2Os and add the same number of OH minus in the opposite direction. OH minus. Then we find out the number of electrons. But here the question is only how many number of OH minus. But here for this modification 10 OH minus ions are required. Okay. Okay, next also do the same thing for here also. That is in this reaction. Do the same thing for this reaction also. IO3 minus I minus 1 iodine, iodine, 3 iodines, there is no iodines, so 3 H2Os. Here there is a 6 hydrogens, there is no hydrogens, కాబట్టి so we have to take 6 H2s and opposite direction, add the same number of OH minus ions. Means in this reaction we are getting the addition of hydrogens at right side, but here the question is given only the number of OH minus added at the left side. So the number of the OH minus ions added is equal 10. Okay, these are the somewhat different problems compared to the other one. Okay, so even if you are having any other doubts also, you can message me. Okay, just practice it many times, then only we are able to remember the reactions and the procedure. Okay.